A recent announcement from NASA regarding a newly captured image from the James Webb Space Telescope has sparked intense discussion across the scientific world. According to early reports, this image may represent one of the most unusual and controversial observations ever recorded in modern astronomy. Scientists describe it as something that could potentially challenge our current understanding of the universe itself. Since its launch, the James Webb Space Telescope has delivered astonishing discoveries: distant galaxies forming shortly after the Big Bang, newborn stars emerging from dense clouds of gas, and detailed atmospheric readings of faraway exoplanets. Each of these findings has expanded what we know about space. But this new image appears to go even further. At first glance, it looks like a simple deep space region, perhaps a faint galaxy cluster or a distant nebula. But closer analysis revealed something far more unusual. The structures captured in the image do not match anything currently known in astrophysics. They are not typical galaxies, not nebulae, and not standard star-forming regions. Instead, they appear to form patterns that do not fit any established cosmic classification. What makes the observation even more striking is the scale of the region itself. The image appears to show an enormous stretch of space extending across billions of light years, with vast empty regions interrupted only by faint, thread-like structures. These delicate formations seem to follow a strange and subtle order, almost as if space itself is shaped by invisible rules we do not yet understand. In standard cosmology, the universe is described as a web of matter made up of galaxies, dark matter, and vast empty voids. This structure has been confirmed by decades of observation and remains one of the strongest models in modern physics. However, this new data has raised questions about whether that model is complete. Unlike known dark matter structures, which tend to cluster around galaxies, these newly observed formations appear more scattered and irregular. They do not behave according to expected gravitational patterns. This has led some researchers to suggest that we may be seeing something entirely new, possibly an unknown form of matter, energy, or even a previously unrecognized stage in cosmic evolution. One theory proposes that these structures could be remnants of the early universe, left behind during the formation of space and time itself. Another suggests they may be influenced by unusual behavior of dark energy in certain regions of space, causing uneven expansion across the cosmos. If that is the case, it could mean that the universe does not expand uniformly, but instead behaves differently depending on location, accelerating in some regions while slowing in others. Even more extreme ideas have been proposed. Some physicists believe these patterns could be cosmic defects, similar to cracks or scars, left behind as the universe cooled and expanded after the Big Bang. These theoretical structures are thought to exist as one-dimensional distortions in spacetime itself. If such ideas are correct, then what we are seeing may represent the underlying framework of the cosmic web in a way never observed before. However, not all interpretations stay within known physics. Some researchers suggest that the image could hint at exotic forms of matter or energy that do not interact with light or normal forces. These hypothetical substances might exist in hidden dimensions, completely invisible to current detection methods. If true, this would mean that the telescope may have indirectly observed aspects of reality that exist beyond the limits of conventional physics. Even more speculative theories propose that these strange voids could contain structures from parallel universes or higher dimensional spaces that interact weakly with our own universe. In this interpretation, the vast emptiness seen in the image would not actually be empty at all, but filled with hidden layers of reality that we cannot directly perceive. This possibility also changes how scientists think about life in the universe. For decades, the search for extraterrestrial life has focused on planets with conditions similar to Earth, liquid water, stable atmospheres, and energy sources like stars. But if the fundamental nature of space itself is more complex than we thought, life may not be limited to planetary environments. It could potentially exist in forms we cannot yet recognize, possibly shaped by physics very different from our own. The James Webb Space Telescope was originally designed to look deeper into the past than any instrument before it, observing galaxies that formed over 13 billion years ago, near the beginning of the universe. But instead of only revealing ancient history, it may also be exposing hidden aspects of the present structure of reality. One of the most unusual features of this image is the near emptiness of certain regions. While cosmic voids are expected in large-scale structure, they are usually not completely empty. They still contain scattered galaxies and traces of matter. This particular region, however, appears unusually smooth and silent, as though space itself has been stretched thin or reshaped. Within this emptiness, faint filament-like structures appear to glow softly. They seem to pulse or repeat in patterns that do not match random distribution. This has led some scientists to describe them as possibly ordered, though the cause of this order is still unknown. If confirmed, this could suggest that spacetime itself is not smooth and uniform, but instead shaped by deeper fluctuations, regions where physical laws may behave differently. Some theoretical physicists have even proposed that what we are seeing could be a boundary between our universe and another, an interface where multiple universes interact, sometimes referred to in multiverse theories. If that interpretation is correct, then this observation could represent one of the first indirect glimpses into a larger cosmic system beyond our own universe. However, these ideas remain highly speculative and far from proven. The scientific community continues to analyze the data carefully, and many alternative explanations are still being considered. What is certain is that the findings have reopened fundamental questions about cosmology. Models that once seemed stable may need revision, and long-held assumptions about the structure of the universe may need to be re-examined. Despite the uncertainty, one conclusion is becoming increasingly clear. The universe is far more complex than we once imagined. It is not static or simple, but dynamic, layered, and still full of unknown structures waiting to be discovered. The James Webb Space Telescope has once again reminded us that every answer in science often leads to even deeper questions. And as researchers continue to study this mysterious image, one question remains at the center of everything. Are we witnessing a completely new structure of reality, or just beginning to understand how little we truly know about the cosmos?